Good afternoon. Welcome to course Thermodynamics of Materials. Today we are into lecture 115 and 116. We are continuing with solution thermodynamics as usual, and we have taken a new topic today that is alternative standard states. There are two types of alternative standard state. One is based on Henry's law. These two types we will discuss actually. One is Henrian 1 mole fraction standard state, and the other is Henrian 1 weight % standard state. This will be very useful in steel making problems and steel making systems. So, so these are very important for us. Alternative standard states. The concept of alternative standard state, we are used to Raoultian standard state. The only one standard state so far we have considered, that is conventional one, that is Raoultian one. What is that Raoultian standard state? You may remember that it is actually for solid and liquid, it is pure state at 1 atmospheric pressure, and for gases it is 1 atmospheric pressure, and both actually and at the temperature of interest. So this is this is the only one standard state that we used, and the activity with respect to that standard state has got the symbol A. We are all along used AI or AB, activity B. A the symbol for Raoultian standard state. That I will show you here. The figure I will explain everything, but have some let us have some talk on this, some introduction maybe. That is, but this is actually the common standard state, that is Raoultian standard state, very easy to follow. But today we will introduce this based on Henry's law. Acha, suppose this is figure 1 first of all. This is actually now, has been fenced like this, and this figure will be actually written because we will discuss this standard state with reference to this figure. So you please first follow that. This is the plot of. I will explain this. Explanations are here. I will go through them. But quickly, in summary, that is, these are also summary. The summary of the summary. Okay, and the gist of this figure or the main thing about this. This is a plot of first of all activity B versus XB. This AB, as you know now, we should be very concerned about the standard state. What standard state? Because there are a number of standard states coming. Raoultian standard state, and alternatively Henrian 1 mole fraction standard state, and later on Henrian 1 weight % standard state. So we should know, activity must have a reference of standard state. By definition, activity, fugacity divided by fugacity of the standard state. FB divided by FB0, activity of B, you know this. So standard state is actually compulsion for activity definition. No standard state activity has no meaning. So this activity B, as I tell you, remember this symbol which you have used, and we are still maintain that is Raoultian activity. So AB, so I am a little bit concerned today about the reference state. So AB is the activity of B with respect to pure B as standard state. Pure B as standard state means it is Raoultian standard state. So it is Raoultian activity, and the symbol is AB, is plotted against XB. This goes from 0 to 1, and when 0 A and when 1 it is pure B, pure A to pure B, XB, and AB also moves from 0 to 1 as it should be, and this O is a point. This the origin you may call it. So O, what is the name of this Raoultian? So this dotted line you follow, O dotted line is actually Raoult's law. O N R. This dotted line. What is the Raoult's law? Raoult's law line, and it is actually equation is, as you know, AB is XB. These are written here, but you just follow me. easily will understand them, or you will easily grasp them. So this is Raoult's law is easy. Then I consider the deviation from the Raoult's law, which is that O N P R. This curve, you see, this curve is the deviation from Raoult's law, and its equation is obviously activity B is gamma B x B. Gamma B is the activity coefficient, and we will call it Raoultian activity coefficient because Henrian activity coefficients are coming. So very specific now, just Raoultian activity coefficient as we know. But only one point has to be noted very seriously, that this curve is not all along actually non-linear. There is a linear part in the dilute regime, which we call the regime of Henry's law. So where the linear part is up to where? O to N. Follow. O N P R. O to N is linear. But although deviation, it is deviating from the Raoult's law line. This Raoult's law line is deviation. But this deviation is a special type of deviation which shows linearity with respect to activity B versus XB. When it is linear, that means gamma B for this region, for this domain, for this segment ON is constant, because what is gamma B? You remember gamma B is by basic definition is gamma B basic. The basic definition of gamma B, this rough work, gamma B is what? AB by XB. And for linear relation, DAB by DXB is the slope. Linear behavior, linear segment. What is that linear segment? ON. Slope is a constant. What does it mean? Gamma B in this linear domain, DAB by DB slope has not changed, same slope. Then after that slope changes because it is actually taking following a curve, non-linear. So all the time it changes. Now this time you may recall that I said something, that regular solution and Henry's law incompatible. This I said. Why? Recall that. But this actually clarified this point today. But why I am regular solution, if you recall this is rough work as if this. Regular solution model, why? Regular solution says gamma B cannot be a constant. No, means no linearity, no linear segment, even in the dilute domain. No, it is all along will change. Gamma will change its composition. Why? What is the remember what is the equation? Ln gamma B is alpha x square. Recall this. RT ln gamma B. RT ln gamma B is alpha. It's okay. Okay, it's fine. It's fine. RT is okay. So what does it mean? Gamma B is function of composition. Xa means composition. So gamma B all the time change its composition. But here you see, as you change the composition, O to N, composition changes. Gamma same. Gamma remains same. And what is the special name to this gamma? Is called gamma B0. As we said, the gamma B at XB is 0. It's called gamma B0. But anyway, so it is in contrast with this is linear segment, this is Henry's law here. So Henry's law says it should be gamma B initial part is a constant. Means activity B versus XB relation is linear. So gamma B is same, constant, and in that domain. But regular solution model, or for that matter modified regular solution model, says that gamma B should be function of composition all the time, from the very beginning to end. So there is a inconsistency. So this actually can be resolved this way. I tell you what. I tell you two things is this. even though you consider this, even though you consider that it is this car, suppose you see this is your so-called Raoult's law, and then it is there's a car. So car, see, however we draw, there should be a linear part in the very small concentration domain. In the very small concentration domain, also in the yeah. You see, you draw this, anyhow draw. See, see, you will have a small. That can be possible, but all that same, it is essentially linear. Mathematically, if you say this is the mathematical equation, then it will be all the way non-linear. But essentially for the mole concentration values, when HB tends to 0 or very small dilute concentration, then you see this is so this is almost straight line, so linear. So this is one reason that I have considered that it is essentially straight line. That's how you have considered. It can be very small domain, small concentration range. Okay, yeah. But I have shown in this diagram it is up to O to N extended. Why I have drawn it extended? For the sake of clarity, so that the diagram can be drawn clearly and can be followed well for the students. So this is the reason. It can be very small, very small. So all the things you always have. I tell you, I give an analogy. Analogy. See, I'm trying here also. See, carve. This segment, looks like a straight line. This is the explanation. Or this you can consider. This is the one reason. Another reason is this. You see, analogy. Analogy is what? Suppose you draw a sphere or circle. Circle. See, if you draw the circle, you will see for the small value, small change in distance along the circumference. Along the circumference, this is almost straight line. Or if we still enlarge it, still this will be more so, greater and greater. Greater and greater. Here you can see this is for this zone, straight line. Yes, straight line, straight. Not exactly straight. Essential. Cannot be straight. Theoretically cannot. This is circle. Car, sphere, car. Best example is the Earth surface. What do we feel? This is the Earth surface I am standing on. So it is supposed to be curved. Okay, but it's supposed to be curved. So, but as we stand on the Earth surface, we have a feeling that it is a flat. So do you feel that it is actually it is moving from taking actually a circular shape? We don't feel this. It looks like flat surface. So because its radius of curvature is immense, Earth, huge, gigantic value. Okay, so for this looks like flat. So this is actually appears to be. So essentially, maybe when it is essentially means it may be considered to be correct actually. So this is the reason why you have considered. Still another is, I tell you what, maybe possible regular solution is not obeyed. instead what is it called? Henry's law is obeyed. One example I can give you, or maybe other system also. In iron nitrogen, Henry's law obeyed. Iron nitrogen system, Henry's law obeyed. Maybe other systems also. This I will discuss why and what is the reason that iron nitrogen system exhibits Henrian behavior later on. But for the time, we have considered that this is essentially straight line, and this has been shown in an enlarged way so that the figure is clear, nothing else. Given this, so what is the equation of this part? This linear part. Linear part has special name. This is general name is AB is sorry. The general name of this card, what is deviation from Raoult's law, is equation is AB is gamma B times XB. This one. But this takes a special name, that is gamma B at XB is 0. Because this, when it is constant slope, so gamma B wherever you take, in this linear segment, same value, same gamma, as I showed you here. Gamma same. Same, because same slope. Gamma is given by the slope. So in this segment, when gamma B constant, so we usually consider 0 at 0 value. Gamma B at 0 value. Gamma B at XB is 0 to at XB is say at n. So this I discussed actually. So that's why we actually say 0 has a special importance and special is a special value. So we can very easily refer to this point. So we have said that it is the gamma B at XB is 0. When it means, I tell you what, in the ON, gamma B0 is the activity coefficient, and that remains same over the concentration range ON, over the length ON. Here O to N, same gamma n. This is this curve, same gamma. And what is this known as gamma B0? What is gamma B0? Because gamma B at XB is 0. That is called gamma B0. This I said. These are all written here, but this I am introducing. So this is this one, and what else? And this is the Henry's law line. I tell you what. Now actually I give you the main thing. This Henry's law. Actually, by the way, what is this? What is this? R. R is the Raoultian standard state. R is the Raoultian standard state. This I have said. This is actually pure B. And if you I'll discuss this at time. Start again with the figure, as I have already told you. And yes, you extend this ON hypothetically, or say extend mathematically. Extend this. This is this. Remember one thing. This ON, this ON is also deviation. Remember, Raoult's law is here. This is deviation. Now you extend this ON to this point. XB is 1. Up to this point, then you reach this point called HMF. H, actually point H, but MF for mole fraction. MF stands for mole fraction. This is actually because we have another H weight percent. That's why to distinguish these two, this point is known as HMF. But this is a point. Point means state. This is a state. This is our alternative standard state. Fast alternative standard state based on Henry's law. Extension of Henry's law, because Henry's law is valid up to in the dilute regime, but we are forcibly extending it up to XB is 1 and get the alternative standard state. The name is HMF at this state. This state is the alternative standard state. This is, let us see, and now we will have to discuss all other things. So start. It is better now we follow this. With this introduction, with this So as I have told you here, AB, as I told you, this I have already explained everything. Okay, let us go ahead. This is a binary system, AB. Okay, explanation of figure 1. This is a figure 1. Remember, this will save. Actually, will keep it intact, and will base our discussion on this figure, and will develop many other relations based on this figure. So, explanation of figure 1. Good. What is this? R. Start. R is the Raoultian standard state, pure B. What is that? Go ahead. Raoultian R. This Raoultian standard state, why it? Or this is pure B. XB is 1, pure B. Physically pure iron, pure B, at which AB is 1. Why AB is 1? Go ahead. So AB is increasing, AB versus XB, AB is increasing. And when it is XB is 1, AB is 1. Read here. AB is read here. 1. So at this point, activity of B is 1. So activity of B, we call activity of B with respect to RSS, means Raoultian standard state. This we have been using so far. We have used from very beginning this activity. So no difficulty. Second, HMF. What is the HMF? As I told you, extend this mathematically, theoretically, extend this linear part to hit XB is 1. XB is 1 at the point HMF. This point is HMF. So HMF is H mole fraction. MF is short for mole fraction. Careful. So we'll use MF often to save, save actually space. Save actually, so that we can we save time, save space, save time. So H mole fraction. What is this? What is this? H mole fraction is what? 1 mole fraction Henrian standard state. What is the name of this? I have written here. Henrian 1 mole fraction standard state. This HMF. It is a state, point, any point is a state, states, all are states. M is a state, P is a state, state. So, it is 1 mole fraction, means XP is 1, Henrian standard, this is the name. 1 mole fraction, this is topic B, Henrian 1 mole fraction standard state. Sometimes we say 1 mole fraction Henrian standard state, it's nothing, So, two types of Henrian standard state. One is 1 mole fraction type, another is 1 weight percent type. 1 weight percent type will be discussed later on. First we finish 1 mole fraction, then we will be very confident and strong actually, and we will actually use to this type of alternative standard state. Then we can very more easily or with more with less trouble we'll actually can handle 1 weight percent Henrian standard state. Start. So this is 1 mole fraction Henrian standard state. This something is written very serious, non-physical, hypothetical. This is non-physical. What is this? 1 mole fraction standard state. What is this? Raoultian POB is the standard state. Both are XB is 1. But Raoultian is pure iron, pure carbon, pure silicon, as we have already used. Pure Fe, pure FeO, pure nickel oxide. So this. But this is also 1 mole fraction. But this is hypothetically extrapolated. The Henry's law, which is valid in the dilute region, is extended to XB is 1, and then you get XB is 1, and it actually get this ordinate it hits HMF. So this HMF, the point, the state, it is called Henrian 1 mole fraction standard state. This also is said here. 1 mole fraction means XB is 1 standard state. Why it is hypothetical? Because it is not pure B. XB is 1, but not pure B. Pure B where? Here. And they have different activities, different energies, different entities. This is hypothetical. This is innovative. And hypothetical and non-physical, these attributes, about how important it is. This concept is more important than many physical things. This non-physical concept is more important than many other physical quantities or physical things, or so more involved and more serious. This actually you will follow soon why it is important. Very good. So this part is non-physical. So you always say, what is this? What is this? It is pure B. No, it is 1 mole fraction. 1 mole fraction B Henrian standard state. Why Henrian suddenly? because it is after Henry's law. Henry's law up to Henry's law is the dilute region linear part. Linear part is Henry. So ON. After that, not Henry. This breaks into this coastal. So now the equation for Raoult's law line, Raoult's law is what? O M R. Remember this is O here. O M R. The equation for Raoult's law line, as you already know, everyone knows, AB is XB. Okay, activity. Remember, whenever AB is the activity of B with respect to AB is what? Activity of B with respect to pure B as standard state. AB, the y-axis ordinate activity of B with respect to pure B as standard state. So we have to be careful the reference state, reference standard state. So it is pure B as standard state, that is Raoultian. So AB is XB. Next, the equation for the curve O, well, O, yes, very good. O P R. This curve O P R, which covers N also. O P R, which deviates from Raoult's law, is obviously AB is gamma B XB. Gamma B is what? We know it is Raoultian activity coefficient. We have to use this Raoultian. Previously we used to say activity coefficient. But now we should insist on the term Raoultian because there will be Henrian activity coefficient to avoid any confusion. So give Raoultian activity coefficient symbol gamma. Symbol, please note the symbols. Raoultian activity A, B, A, I. This is gamma B likewise. Gamma is the Raoultian activity coefficient. Raoultian activity coefficient. Next, the equation for the linear segment on ONPR means that deviation on ONPR which follows Henry's law. This segment ON over which Henry's law is obeyed. As you already know, we already have studied this. What is the equation of this? Is the equation is AB is gamma B 0 XB. Gamma B XB, but here in the special, this zone is dilute zone, dilute linear zone. AB is gamma B 0 XB. What is gamma B 0? Again, remember, is the Raoultian activity coefficient at 0 concentration. 0 for 0 concentration of B. That is XB is 0. So this, okay. So this is, this. Hence, the equation for Henry's law line ON, say ON, or ON, if we extrapolate, straight line, same, ON or ON, HMF, same. So, equation. So, ON or ON, HMF, equation of ON or ON, HMF is what? What is the equation? Is AB is gamma B 0 XB. Very good. Oh, so very good. So the what is the equation? The equation of the Henry's. What is this? The equation of the is AB is gamma B 0 XB. Okay, this is okay. This is already discussed. AB is gamma. HMF, as I have already said, is known as the Henrian 1 mole fraction standard state. Already mentioned. I have already mentioned here. Okay, here somewhere here. Okay. Already mentioned. HMF. Here. Already mentioned. So repeat this part. So what is the equation? See, I am going to give you the 3 equations for the same line. Which line? This Henry's law line. Or this line ON or its extrapolation. Extrapolation up to HMF. Follow this line. ON, extrapolation. This line will be represented by 3 equations. Will be described by 3 equations. And 3 equations alternative. First, already one, what is this? AB is gamma B 0 XB. Seeing this, you should know it is in terms of Raoultian activity. And gamma B 0 already said, already discussed. HMF is known as, what is HMF? Just as I mentioned here, HMF, and also mentioned there, it is Henrian. This state is Henrian one mole fraction standard state. That is the alternative standard state. So Henrian is known as one mole fraction standard state, already mentioned. At HMF, for which XB is 1 mole fraction, XB is 1. Here, AB is how much? AB is how much? This is AB. AB is how much? AB is, follow, what is the equation? Follow the equation and put the value. Equation, AB is gamma B0 XB. This is the equation. And what value it takes at XB is 1, gamma B0 XB1, where is this? Is what? At HMF, for which XB is 1, AB is gamma B0 XB, and since XB is 1, at HMF is gamma B0. So what is the value of activity AB, Raoultian activity? At this point, how much? It is? How much it is? Wait a bit. Is what? What is this? Is gamma B0. Is gamma B0. I have shown here, this is wrong. This is wrong, actually. What? So I am giving you. This is, remember, don't, this is different activity, HB, Henrian activity. And these values, 1 by gamma B0, coming later. For the time being, then you have got up to what? AB is gamma B0. Following this equation, AB is gamma B0. AB value at this point, at this state, at this standard state, is gamma B0. So how will you show it? I will show in the AB scale, gamma B0. So I have drawn a dotted line to show this value gamma B0. So activity of B at this state is gamma B0. You read this scale, AB activity, Raoultian activity scale, and read the Raoultian activity here. So 0, 1, so far 3 I have got. This part is over. Gamma B0. Then what is the last thing that I have said here? Shown on the gamma B0 shown on the AB axis. On the, not here. This is different AB axis, not like this is HBMF axis. Don't worry about this part. This part don't think. Consider this part. You consider, don't think about this. And this is still remote. Much later. This one. So you consider this. What is this? Gamma B0. See, so AB is gamma B0 here. So here, last is HBMF. Is what? HBMF. This scale. This is AB, HB. This is one activity. This is another activity. This is with respect to Raoultian. We have so far used it and we will maintain that AB. And this is HB for after Henry's law. HBMF mole fraction, because there is another coming 8%. So that's one. Otherwise HB is good enough. AB, HB, good enough. But just since another is coming 1.8%, so it is HBMF, this activity value. So it says HBMF is activity of B with respect to what? Henrian 1 mole fraction standard state. MF means mole fraction. So Henrian 1 mole fraction standard state. As I have already said, two standard states we are considering, two alternatives. The first one is Henrian 1 mole fraction standard state. So HB is this. Note HBMF is shown on the parallel ordinate. Not this. HB shown at this ordinate. I have drawn another line. This ordinate is this ordinate. HBMF. And I have shown here 0, 1 by gamma B0. I will explain why. This scale, according to this scale, these values are there. This point it is 1. This point follow. This point AB is how much? This point AB is how much? Read gamma B0. This point HB MF what? Read 1. This I will explain. Okay, this will 1 and other things I will explain. But this is the scale. So two things important. This is the Henrian activity values at any state in this diagram. Henrian activity means with respect to Henrian standards. Any point you have AB value. What is that? With respect to Raoultian standard state, which is pure substance. And Henrian is, and this is Henrian standard state 1 mole fraction. Respect to this point as the standard state. And Raoultian is this point as the standard state. Activity means always it has a reference to a standard state. So HMF, okay, very good. So this is, so two things. One is this is the, what is the standard state? Raoultian, this point, this state, point means state. And this, what is the Henrian standard state? Mole fraction though, mole fraction say, mole fraction. So this point, sorry, I said this point, 1 point is over, clear. What is this HB mole fraction? See H, small hb, this is activity, Henrian activity of B. With respect to what? With respect to Henrian, corresponding Henrian standard state, what is this? With respect to this standard state. Henrian 1 weight mole fraction standard state. This is this value. These values are like I give you, show you 0, 0, 0, here 0, here 0, here 0, here 0, but other here 1, but this is gamma B0. Different. Raoultian gamma B0, Henrian 1. Why? This I will explain. Okay. And here 1, it is 1 by gamma B0. Very interesting. And then also I add you, when I consider the second alternative, HB weight percent, I consider this still another, then this will be still another parallel ordinate, and this is the scale. This is the scale for this. This will be actually, this I will show you. Okay, 0, 1, and approximately 100, etc. I will give you this. So this, okay, so first you complete. So this part is over. Next, let us now get into action. See, first thing is, I tell you what. See, follow. So, 3 equations of the same line. What is the line? Henry's law line. What is the name? ON, say. But since it is extrapolated to HMF, it is ON HMF. Same. What is the equation? We know. One we have already know. What is Raoultian? In respect to Raoultian activity, AB is gamma B0 XB. This we know. With respect to Henrian HB. AB HB. Raoultian, Henrian. HB is how much what it is? We don't know. This is our job. Next job, to find this equation of the Henry's law line in terms of Henrian activity. Or Henrian, yes, in terms of HB, HBMF. Okay, we get this equation. What is this? That is activity of the B with respect to Henrian standard state. What is Henrian standard state? Remember this point. And this is the scale, like activity scale here to here. And this is the state, Raoultian standard state. And this is the Henrian standard state mole fraction. So next, we should move on to the next one. So I have to, these 3 and 3, 6 equation very valuable. We'll derive this. But I have saved this, we'll often refer to this. So this part I will not. This part I will not disturb. This is very important. This part is very important. So this I will share for the entire lecture. Today or tomorrow also. Let us see how much we can finish today. So I am removing this. This discussion is done. So very easily I can remove and create some space. Binary system maybe you have understood. I am removing this line also, so that I can get space to write on, all removed. Only this figure, as has been given outlined here. This is a figure 1 will be written, and these 6 very important relations that will derive in the course of discussion, I have saved them because they will be often referred to subsequently. That's it. So start from here. I think I need more space because these are already occupied. These are already occupied. It cannot be written on. So I will remove this one. Since this you have already understood, today topic is alternative standard state. Good, very good. And if you don't mind, I am removing the solution thermodynamics continued because this is already the space here. This part I will not touch. Let us start. So what is the job? To find the equation. First job is to find the equation of the Henry's law line in terms of Henrian activity or in terms of Henrian standard state or in terms of Henrian activity. HB means Henrian activity of B with respect to Henrian standard state. Or say Henrian activity means activity of B with respect to Henrian standard state. Activity of B with respect to Henrian standard state. Henrian activity means already implied Henrian standard state. Don't have to say. But we could say activity of B with respect to Henrian standard state. This is activity of B with respect to Raoultian standard state. Enough is enough. Okay. Bapu. So just check if it's okay. একটু আমি ঘষছিলাম খুব ওকে তো আমি put it back there. একটু সাইড খুব হ্যাঁ 44 minutes. Okay, very good. ठीक है 44 minutes. Thank you. So move on to this our job. Okay, let us start. Remember, so now I'm writing this. Now, what is the job? We are to find the equation for For the Henry's law line, Henry's law line, when Henry's law, when, but extrapolation is just linear extrapolation. The same line, same straight line extrapolated, or ON HMN, or ON HMF. Remember, HMF is a point in state. That is the Henrian standard state alternative. What is one mole fraction Henrian standard state? And these are the activities with respect to that standard state. They are called Henrian activity mole fraction, HB mole fraction in short. So ONHF in terms of Henrian one mole fraction standard state, standard state, standard STD, short for standard, standard state. Okay, we already have the equation for the equation short for ONHMF in terms of Raoultian standard state. Raoultian standard state, RSS in terms of Raoultian standard state, which is what? AB is, what is that? Already you see written here also. AB is gamma B0 XP, that is the equation of this segment. I have already discussed. AB is gamma B0 XP. This is our first equation. Then what you have next? Establish the relation between the two standard states. Two standard states, namely which are, that is what is the standard state? That is Raoultian standard state, Raoultian standard state, which is in short RSS, and Henrian mole fraction standard state. Henrian mole fraction short MF, mole fraction standard state. What is the, how you symbol here? HSS, Henrian standard state. MF, right here. Henrian mole fraction standard state. Symbol HSSMN. And Raoultian standard RSS. Okay. Very good. Very good. RSS. Henrian standard state HSS. As follows. As follows. Okay. What is this as follows? Let us see. Let's begin with the equality. The equality is what? I was writing GB bar is GB bar. That's why I'm writing this identity. GB bar is GB bar. Then what I'm doing, or you recall this, you recall this, very important. I write somewhere, I write here at the underneath GI bar is GI 0 or 3 ln AI. Recall this concept. What is this? You know, this I said GI bar is GI 0 with respect to this for any state non-standard state, this standard state, and activity of this non-standard state relative to activity means relative to with respect to relative to this standard state. This I said how? Remember in the class previously, this is the activity of this state, impure state, and activity means some relative to this standard state. This is whole thing. So do this here. GB bar is I am writing. We have two standard states in the frame. One is Raoultian standard state, another is Henrian standard state mole fraction. Right? One by one. Left hand side Raoultian. How right? GB0, GI 0. Remember, GI bar minus GI 0 is known as GI bar M. Mixing. This difference is GI bar M is RTL and AI. Recall. So recall this mixing functions, solution also. These are used. This so it is very common, very important, very. So everything is important, but anyway, this is often used. GI bar is I am writing GB 0. What standard state? Now careful about writing. RSS. This standard state is RSS. What is this? You know, POD. POD. Plus RTLN. Right? Since I'm actually showing you one step extra, as if I'm writing activity of B. This AB, this AI I am writing activity of B with respect to Raoultian standard state. Okay, GB bar activity of B with respect to Raoultian standard is what? Tell me. Right hand side GB bar is what? Similarly, GB 0, but not what I write. I want to get the relationship between Raoultian standard state and Henrian standard state. So choose another one. Choose the relevant one. The other relevant one, which is Henrian standard state. Okay, and perhaps you will give always tag. You have to tag always. It will take some space, but I cannot help it. Plus what you write here? Plus I don't have space. I have to write underneath. Maybe plus R like this. RT ln activity. Again write activity. Activity. Symbol I am not giving on purpose. Next line. Activity. When I have written AI, you know this implication is Raoultian activity. We have when we are discussing it, we are only discussing Raoultian standard state. So today only we have started alternative standard state. Activity of activity of B with respect to Henrian standard state mole fraction. Activity of B with respect to the Henrian mole fraction standard state is this one, this state. So this part, or GB0 RSS, Raoultian standard state. So Raoultian standard state is here and Henrian standard state there. The HBMF name, HMF, sorry, HMF is Henrian standard state. One more fraction, HMF. Very good. HBMF is the Henrian activity of B. Henrian activity of B. Okay. This is the standard state. Here, AB is the Raoultian activity of B. And relative to Raoultian standard state, this is relative to Henrian standard state. This is relative to this point, this state. This is relative to this state. This is relative to this state. This is relative to this state. Let us see what happens. Let us see. Interesting. Plus, what shall I write? You know very well what is the symbol? RTLN, Raoultian standard state activity, AB. AB. Very good. Good. Is GB0, right? HSS, MF, plus, what is the symbol here? RTLN, not A. Not A with respect to Henrian standard state. Symbol different. It is not Raoultian standard state. With respect to not Raoultian, but Henrian. Symbol is Henrian H. B, I'm sorry, RTLN, HB, since mole fraction is there, HBMF. RTLN, HBMF, okay? RTLN, HBMF, this HBMF. This is the Henrian activities coming there. So this is okay, HBMF, okay, RTLN, HBMF. So call this, shall I have get space? 1 equation 2. Oh, unnecessary, sorry. Equation 2. Equation 1, equation 2, good. So, equation 2. Note. So, clearly note symbols clearly note. Note AB is the symbol of activity of B, at any state. Activity of B where? Activity of B where? We say what is the activity of B? At any state. For example, here. What is the activity of B here? If someone asks you here, you will say activity of B is gamma B XP. What is XB? Read from this. XX. Gamma B that. If you know the gamma B, then give the value. Symbol of activity. What are you going to write? Activity of B at any state. At any state, say state P. P I have given just for. Just P is actually randomly I have chosen a P here. I could have chosen here, chosen there, P. Any state P. And activity at any state P with respect to Raoultian activity of B at any state of B. Activity of B at the state of B given by point P. That is state. So at the activity of B at any state of B, obviously, B at any state, say state P of B, activity at any state of B, say state P, with respect to AB with respect to Raoultian standard state. And what else? HBMF. Likewise, HBMF is the symbol of activity of B at any state of B with respect to what? Henrian standard state mole fraction. Please note this. So these are symbols. Symbols I have clarified, okay, with respect to Henrian standard state means okay, this part is okay. Next, with respect to or, keep on doing, or 3 ln activity B is just transpose this GB0 HSS MF minus GB0 RSS plus what remains here? RT ln RT ln HB MF. Or now you have to find this value. Then you will get a relation between this AB and HBM. That will be used here. Then you will get the alternative equation of the Henderson line in terms of Henrian activity. In the second one is already written HBMF is XP, but we will derive this. The third will be coming after 108%. So 3 equations represent the same line because activities are different. Good. Arterial activity. What is this? I'll suggest something here. What's the meaning of this, first of all? In the first place, what it means? Tell me. The free energy, standard free energy of this state. This is already a Raoultian standard state, so standard. Free energy of this state means Raoultian standard state. Free energy of the Raoultian standard state means R, and the minus free energy of the Henrian standard state, Henrian mole fraction standard state, that is HMF. What is the difference in free energy of these two gentlemen? This gentleman and this gentleman. Both are standard state, different kind of standard state. What is the difference in free energy? Do they have same free energy? First of all, you see this is here, that is there, they have different free energy. But very easy way to find this, and you should learn this practice, okay, acquire this skill. How to do this? I give you this clue. From this I am giving the clue. Follow this. Gi bar, or I am writing this line. I am writing Gi bar minus Gi0 is R3 ln AI. It's okay. Here you will get the answer here. Follow with me. First of all, again I write what is the activity of I. Tell me what is the meaning of this. You tell me. Activity of which state? Which? I am removing this. I don't need this. Okay. I am removing the. What is the which refers to the activity of I? Which state? Now this impure state. Relative to or with respect to which state? This is the whole message. So whenever you come across This, you consider this, put it in this format, and then you'll be safe. You'll be safe. This is the best way to understand. Put it in this format. What I suggest, this GI0, it was your Raoultian previously, because this you studied, only we are used to study Raoultian only. So this is Raoultian, this is Raoultian. GI bar, this is not GI bar. But I tell you, anything other than this gentleman called Raoultian standard state, this, anything other than this, anything other than this is GI bar. Treat it as GI bar. Anything other than GB0 RSS, you please treat as GI bar. Then you have answered. GI bar minus GI0 is RTL and AI. GI bar is treat is a GB bar, or whatever you call it. Okay, GB bar minus GB0 is RTL and AB. AB ki what? But AB should be clearly mentioned. AB of what? AB of this side. So AB means AB should not say this is actually activity of yes, AB is okay. AB of this one, of AB of this state. You see, this related to this. So AB of this state with respect to Raoultian standard state. With AB means see Raoultian with respect to Raoultian, so AB. That means basically what is the AB? What is the AB of this? Whose? This. What is the AB? AB already we have answered. The equation is gamma B0 XB equation, and this is the point where XB is 1. Put XB is 1, what we get? AB is gamma B0. So what is the AB at this point? Gamma B0. Why do you show this in the AB scale? So that's why you have shown there, dotted. Yeah, this side you have shown. This side is reserved for AB, that side for ND. So you have not written there. So answer is GI bar minus GI0 is RT ln AI of this state with respect to this state. Very good question. Is then this what it is doing? What is the, in other words, what is the activity of this state? What is that state? That is the standard state, alternative standard state. What is the activity of this alternative standard state with respect to the conventional Raoultian standard state? With respect to Raoultian standard state. What is the activity of Henrian standard state with respect to Raoultian standard state? What is your activity with respect to this? Raoultian activity with respect to Raoultian activity is how much? Raoultian with respect to Raoultian is 1. But it is Henrian with respect to Raoultian. What is the answer? Go by the equation. This equation is AB gamma B0 XB. And what is this point? XB is 1. So it gives AB is gamma B0. And that we have already shown by this here. So this I will put here RT ln AB is gamma B0, RT ln gamma B0. So before this I write few explanatory lines. Okay. So I write this, what I said. So what is I said? Remember, this is one thing that you have to understand, and this is another thing I tell you. I tell you frankly. Sorry. One is this. This line, what is this? Well, writing this. GB bar is GB bar. Then you write this. One stand with respect to one standard state activity, another expand. GB bar is GB0 plus RTL and AI. This side and that side. This side one standard state, that side the other. Later on you may have solid standard state. One side solid standard state, other side is liquid standard state. Possible? Possible. One side is solid standard state, the other side is vapor standard state. Possible? What is the activity of pure iron with respect to pure iron as standard state? This one. What is the activity of pure iron solid with respect to pure iron solid as the standard state? Answer is 1. What is the activity of same pure iron solid with respect to liquid iron standard state? This will be not 1 anymore. That depends on temperature. Which temperature? Above melting point or below melting point. So accordingly, it will be different. Okay. So if it is, I tell you what, it is above melting point, liquid standard state will be below 1, and this can be shown. Actually, this I am not taking up unnecessary. But these are the things. Say you have a water. See, in a pot you have water. Question. Alternative standard state. What is the activity of water? Means H2O with respect to liquid water as standard state. You have taken liquid water, pure liquid water. What is the activity of pure liquid water with respect to pure liquid water as the standard state? You will say answer 1. But what is the activity of H2O with respect to 1 atmosphere water as the standard state? Suppose this system, actually I should describe, explain more. This is a container, you have liquid and vapor, water, saturated water vapor. Water liquid, water vapor, temperature T. Question is, what is the activity of water, H2O? AH2. Question is H2. Two reference states, two different standard states. One is with respect to H2O liquid as the standard state. What is your answer? H2O liquid is there with respect to 1. With respect to liquid standard state, since it's pure, if the question is changed, what is the activity of water with respect to vapor standard state? Water vapor standard state. Water vapor standard state, you know. What is the standard state for vapor means gas? 1 atmosphere. With respect to that, what is the, suppose this vapor pressure is, suppose you remember our famous 0.69 atmosphere, which temperature? 343 perhaps. Remember. So what is the activity of H2 with respect to vapor standard state? Vapor standard state. What will be the answer? Is it 1? It is. What is the activity of a gas with respect to? What is the activity of a gas? What is the activity of gas? Is nothing but pH2 by pH2 0. What is that is 1 activity. What is the standard state for gas? 1 atmosphere. So pH2 we know we have used number of times. Activity CO is PCO. Activity CO2 PCO. Activity PG. So PCH2. What is the value? Are they equal? 1. Why have changed? Because reference state has changed. But what is same? This is equilibrium state. This is equilibrium state. Equilibrium. What is same? What must be same? Equilibrium. Activity is different. Because activity means there is a reference state. You change the reference state, value change. Who same? Who same? Who cannot change here? Sir, GH2O liquid is GH2O vapor, sir. Whatever you do, sir, this is same. 300 same. That's why equilibrium. Delta G is 0. This is actually application of alternative standard state also. So this will be coming. I'm trying to remove this. Okay. So what is this value? So let me write. Let me write so that it will be retained there. See, I'm writing. See, follow this. Follow this. This again. RTLN GI bar minus anything. Suppose it is GI 0, then it is GI bar. Is what? Write nicely. RT is RTLN activity. Write RTLN activity. AI you don't write. You write flat. Completely open. RTLN activity. This activity, okay, in letters, better. Then what is symbol? Oh, Raoultian standard state. Oh, it will be AB or AC or AI. Oh, it is Henrian. HB mole fraction, weight percent, weight Hb, weight percent, etc. So I am writing first RTLN, let me write RTLN activity of B at HMF, activity of H with respect to Raoultian standard state. Activity of this with respect to H, activity of this with respect to this. So with respect to this, so activity symbol I will give later. Activity of B at this state with respect to Raoultian standard state. Okay, this I said. Okay, this one, this AI of this state relative to this. Here of which state? Of this state gi bar minus gi relative to this, plus what you have, plus right here, right here space here with respect to Raoultian standard state, plus continue RTLN Hb mole fraction. Now we write what is this? Is or RTLN activity of B. Tell me what it will be quickly. What is the name? Since with respect to option A, RTLN. Let me write this RTLN. I give the answer. Also already I am giving the answer. Activity of B, AB rather. Since with respect to option AB or B at this state. That is an alternative sentence, but that state, that is GI bar. What is the activity of B at this state? Answer, I have already explained. Go by this line, AB is gamma B0 XB, at XB is 1, gamma B0, and really shown already, gamma B0. Just put that. Plus this side. RT cancel, RT cancel, RT cancel. Or AB is HB MF gamma B0. Very important relation for us because you see AB HB gamma B0. Okay, I think I will get an equation to this 3 perhaps. Now 2 is here, this is 3. Okay, now let us move little faster because time is 3. Okay, happy. Okay, this is very important. So the quick application is what you know. You know AB, you will get HB. Anytime. You know HB, you get AB. Use this relation. Bridge. This relation is a bridge between two activities. Raoultian and Henrian. Bridge. Use this relation. For example, if you ask me at this state what is AB? At this state what is AB? AB at this state gamma B0. Gamma B0. Then what is HBMF? 1. Gamma B0, gamma B0. Cancel. HBMF is 1. I will show here 0 to 1. This scale, this scale, this scale. HBMF, this scale exact. This line for, sorry, very sorry. This line for this line, this one, not this. This is also this one. And HBMF shown. What is this? 1. Now can you tell me opposite question? Opposite question. Tell me. What is the okay? What is AB and HBMF at this point? Tell me. At R. AB is how much? At R, which is Raoultian standard state, AB means relative to Raoultian standard state, how much? We know 1. Then you are asked, okay, very good, it is easy question. What is HBMF here? Here, HBMF here, any point you can convert. Any point here. A bridge. If it is 1, put it here. 1 is HBMF, the unknown, times gamma B 0. So what is HBMF? 1 by gamma B 0. This scale, follow this scale. Second one. We might say, sir, this is 1, that is 1 by gamma B 0, that is greater than 1. And 0 is what? Where is the 0? 0 is what? Here, okay. So 0 here, 0. AB is gamma B 0, XB is 0, AB is 0, okay, 0. So this point has this point. Okay, I'm sorry, okay, it's okay. 0, 1 by gamma 0. Should be greater than 1 or less than 1. Looks like 0 to 1 should be greater than 1. But how can you say? Can you justify a little bit from your solution thermodynamics knowledge? What is the gamma B? Look at the gamma B. Can you tell me what is the gamma B? Any idea? Value? Remember Raoult's law line, gamma B is 1. Ideal solution. This is deviation. What type of deviation? Negative deviation means gamma less than 1. So gamma less than 1 means gamma B 0 also less than 1. So less than 1 by less than 1 means greater than 1. It makes sense. 0, 1, it makes sense. Very good, very good. So see any point, I can ask you, you will always convert. Okay. Suppose I say at a point AB is 0.2. What is HBMF? Your answer will be 0.2 divided by gamma B 0. Again I say at a point HBMF is 0.7. This is 0.7. What is this? You will say 0.7 times gamma B 0. Now if the value of gamma B 0 is given, you just put in and find final value. Very easy. In a sense, very easy and very interesting. Now move on fast. Okay. So this is question 3. Move on. This is the comment. This is the relation between the activity of B at any given state like say P, state P at any given state with respect to WRT, with respect to two different standard states. Two different standard states. Namely, which are two here? Namely, one is RSS, Raoultian standard state, for which we get AB, and another is Henrian standard state, mole fraction, for which we get HBM. Okay. So this part is over. So call this now. Now let us check. We already have to finish this part. We already have what? Our aim was what? This is actually and some intermediate step. Our aim is to find the equation of this Henry's law line with respect to Henrian standard state, or in terms of HBMF, Henrian activity. This is Raoultian activity equation, Henrian activity. Raoultian activity is what? AB is gamma B 0 XB, and Henrian will be what? Answer we know, HBMF is XP. Is written. 3 equations is written for the same line, but I'll show this. Second one, this is for weight person which I have not started. So we already know, already have from equation 1 equation 1. Where it is equation 1? What we have? Tell me which I have already have from equation 1. The equation for ONHMF means this line, Henry's law line. ONHMF is what? Tell me what? AB is gamma B0 XB. What equation? 1. Now will you compare 1 and 3? Comparing 1 and 3. Comparing 1 and 3, we have what? Both are AB. Both are AB. So what is this? Right? HB MF times gamma B0 is gamma B0 0 times XB. Will you cancel? Of course you will. Or HB mole fraction is XB. And you all said equation 4. You have derived equation 4. And we have already written here. We have already written here. Have you not? Top is in terms of AB, gamma B0 XB. Now HB in terms of HB mole fraction is just XB. Just XB. So very easy. So along this line you can very easily say what is the HB mole fraction. So what is the HB here? This point? At this point, what is the HB? At this point, what is the HB? HB is XB. What is XB? 1. So HB mole fraction is 1. Yes, sir. It's 1. I have shown 1. This point, this 1 means this scale. This HB mole fraction is this ordinate. Parallel. This is 1. This is first parallel. This is second parallel. This is third parallel. HB mole fraction is 1. So very easy. Equation helps you. Equation guides you. So, but develop the equation and understand the deductions, derivations, and okay. This okay, HB is mole fraction. Okay, this is the equation 4. Okay, this is the required. I stop this point. It is not take risks. Shall I remove this? I think I don't need. Yeah, I'm writing here. Yeah, good enough. This is good space. This is the required equation. Why required? Required equation for ON for the same line ONHMF, that Henry's law line in short, in terms of Henrian standard state MF. This is the required equation. This is we have to find first top line. Find the equation for the Henry's law line. Yes, ONHF in terms of Henrian 1 mole fraction standard state. Just remove standard state. In terms of Henrian 1 mole fraction standard state, we have to find, and this is the required. We have found HB mole fraction and shown here. So clear this part. Next is. So let us So I am removing this whole. So removing this unnecessary. So actually I could have not removed this. It is I could have retained this here actually. It start here, and since we had two, we have already got the required one. So remove this. This is the required equation in terms of action. This you have, which is this is the comparing of HB. So I am summarizing it here. Okay. So we have two alternative equations. Careful, careful. Yeah. This figure should not be damaged. Okay. So okay. So so we have two alternative equations for the Henry's law line Henry's law line or its Henry's law if you consider ON and the ON HMF is the extrapolation or its extrapolation same line, only one line here. You may call it ON, you may call it ON HMF, and later on I will introduce another point or another standard state H weight percent at this state, a point state, H weight percent, 1 weight percent standard state Henrian. So then it will be O same on the same line. O H weight percent in HMF. 4 points. O H weight percent is a point state, standard state Henrian. Alternative. We have innovated for its extrapolation to XB is 1, that is up to XB is 1, that is for line, that is for line, which line? You may call it ON, you may call it ON, or you may call it ON HMF. Line ON or ON HMF. What are these two alternatives? This just now we found here HB is H mole fraction. This is the required equation just here. Okay. So first of all, one is right. AB is gamma B0 XP. This one way of expressing Henry's law line in terms of Raoultian activity. Another is tell me HB mole fraction is what? Just pure XB. So what is this? Call this equation. This is AB is gamma B0 is already one. It is already named one, and this is all just now at the end I got this. I wrote here. HBMF is XB. Here I wrote here HBMF. Sorry, I actually removed this. This is 4. This is the last line, and this is the required equation. Is what? Required. 4 HB 4 HB. This is in terms of tell me Raoultian standard state Raoultian activity. In terms of Raoultian activity, Raoultian activity, and this is in terms of in terms of in terms of Henrian mole fraction activity, or Henrian activity, also activity. In terms of Henrian mole fraction activity. Okay. So this is a important one. This you have listed this equation 1 and 4. So you have this. Okay, that is so equation. This is actually got the two equations. And what else today? Today actually I don't have time, some time, but anyway, let us start. Start here. Okay. It's okay. 1 and 4. Now consider the point P. Point means state. Point means state. Point P. Point P seems interesting. Point P, which it does not lie. See, the point P outside the Raoult's law line. It is on the deviation from Raoult's law. Point P. So it is deviation from Raoult's law. It doesn't obey Raoult's law. Point P. And this is the Henry's law. This is also deviation from Henry's law. It is not on the Henry's law line. It is not on ON HMA. So either way it is a deviation. So in that case you have to introduce what? When there is a deviation from an ideal equation, what we have done in case of Raoult's law? Activity coefficient. Introduce. Here also we have to introduce, that is Raoultian activity coefficient. We have so far called only activity coefficient, but now we have to say Raoultian activity coefficient, and here you have to use also Henrian activity coefficient, mole fraction type. This is the point. Consider the point which does not lie either on line OMR, Raoult's law line, that is Raoult's law line, Raoult's law, Raoult's law line, or on or on line what? O, tell me Henry's law line, ON HMF. It doesn't lie. On Henry's law line. Okay. That is at the state given by point P, at the state given by point P, the activity of B in the solution, because this is the P is the impure state. Pure state B is here, physical, pure. Impure, all are impure, except this, all are impure. In the solution, so in the activity B in the solution shows deviation from both Raoult's law and Raoult's law and Henry's law. Hence at P, what is the AB? Tell me, what is at P? AB, what you will say? What is the AB? You know very well. It is not Raoult's law. It is on Raoult's law line. What is that? Raoult's law. AB is XB. When deviation, AB is gamma B XB already written. AB is gamma B XB, and you know 100 times. You have used this. So AB is gamma B XB at P. General gamma B XB. P has a XB, so you can substitute if necessary, but we are not interested. AB is gamma B XB. And what is, so this you got, and so this, because it is deviated from Raoult's law, and since it has deviated from Henry's law, what you write? What is the Henry's law equation? Okay, in terms of Henry's HB, what is this? What is this? What is the equation? HB XB. This line is, entire line is HB XB, HB MF XB. So HB MF is XB EP where on this line, but since it has deviated from EP where on this line, sorry, HB, but it has deviated. This P is outside this. So what you have to do? You have to introduce a corresponding activity coefficient called symbol AB mole fraction. What is this? AB mole fraction is Henrian activity coefficient. This is Raoultian, gamma B is Raoultian activity coefficient. You will write this. Write that. Gamma B is what? Raoultian activity coefficient. Activity coefficient, and AB mole fraction will be what? Henrian activity coefficient, but should be specific about mole fraction. Henrian mole fraction activity coefficient. Henrian is right here is Henrian mole fraction activity coefficient. From this, we know what? There is a connection between these two. You have proved this. Oh, what is the connection between these two? This I showed equation where? Equation 3. Equation 3 I have already showed you, and I have saved here. 3, AB is HB. How much time? 40 minutes. AB is here. Equation 3, between two standard states relation. This actually AB is equation 3. Equation 3. AB is what you got previously. Gamma B0 H MF HB MF. Equation 3. Right here, equation 3 already. Equation 3. Equation 3. We can rewrite equation 5. Or you have named this. This is equation 5. We have go up to 4. Right? This is equation 5 and this is equation 6. We can rewrite equation 5 as what? Gamma B0. Here. Gamma B0 HB MF is gamma B XB. Call it 7. Call it 7. Dividing 7. Dividing 7. Equation 7 by equation 6. Equation 7 by equation 6. If you divide this 7 by 6 means HBMF, or I am writing here gamma B0 HBMF divided by 6 HBMF left hand side. On the right hand side gamma BXB 6 right hand side FB mole fraction. So what you have? HB mole fraction is no cancel. I made a mistake somewhere. We follow this again. 5, rewrite 5. Gamma B0 HB is gamma B XB, okay. Then divide equation 7 by equation 6. Oh, what has happened here? Have you noted? What is this equation? Equation 3 is where? Equation 3 I wrote somewhere, equation 3. Between these two standard states, okay, anyway. Equation 3 here, okay. But you see what I have made mistake, AGB MF is, you have not followed. What is this XB? Where? FBMF. This FBMF. What is this? What is the equation of the line? HBMF is XB. That is on the Henderson line. Since deviation, so it will get a FBMF. I mistaked this. Actually I overlooked XB. So it will be divided by, you divide HBMF left hand side, right hand side, FBMF XB. Take a look. FBMF XB actually XB. Okay. So XB we cancel. Or FB mole fraction gamma B very important relation, and give the name to this. It will be 8, I guess. 6, 7, 8. 8. Every mole fraction is gamma B by B. Now you Note this. Note. Interesting. Easy to remember. Easy to remember. Follow. Follow. What is the relation between three AB and HB? This activity and this activity are separated by what? By gamma B0. This you have note. Separated by, just I am showing for effect, separated by gamma B0. Their activity coefficients are separated by gamma B0 also. They are also, activity coefficients are also separated by gamma B0. See here, you write here gamma, what is the corresponding activity coefficient? Raoultian activity coefficient is what? Gamma. Gamma B. I have already said A gamma B Raoultian. And what is the corresponding Henrian activity coefficient? What is the name? FB mole fraction. HB, FB. So they must be, these are separated by gamma B0. These two are also separated by gamma B0. Very easy to. Same pattern, same pattern. See here, say gamma B is what? FB mole fraction times gamma B0. Gamma B, FB, gamma. So both are separated. Activities and both activities and activity coefficients, both correspond activities of Raoultian and Henrian separated by gamma B0. Raoultian activity coefficient and Henrian activity coefficient separated by gamma B0. This is very interesting observation. Thank you. Thank you very much. With this, perhaps I will not proceed further. It is not possible. Bapu, Bappa, come on. So with this actually we have completed. With this we have completed today's talk and okay, and today's class, and we'll take up 1 weight % standard state. 1 weight % standard state next class. Next class we'll take up and similar relations will come. So that is coming down the road. Thank you very much for your patience and for your interest and for your attention. Thank you. See you next class. Bye.